In the spring of 2016, a woman hiking alone on a trail in the foothills outside of Snoqualmie, Washington, noticed something following her. Not in the way hikers sometimes imagine they are being watched, the peripheral anxiety that open wilderness produces in people who spend most of their lives in cities. Something was actually following her. She caught it in her peripheral vision first, then turned and saw it clearly. If what you just heard makes you want to keep going, stay here. This is exactly the kind of content we make, and there is a lot more of it. Subscribe now so you do not miss what comes next. A mountain lion, moving parallel to the trail at a distance of roughly 30 feet, its body low, its attention fixed on her with the specific quality of focus that is distinct from curiosity. She did what the guidance says to do. She stopped moving. She made herself as large as she could. She spoke loudly and directly at the animal. She maintained eye contact. The lion held its position for approximately 45 seconds, then turned and disappeared into the brush. She walked back to the trailhead without running, which took considerable discipline, and filed an incident report with Washington Department of Fish and Wildlife. The incident was logged, reviewed, and categorized as a non-injurious encounter. It was one of several dozen such encounters documented in the state that year. It produced no headlines. It was not unusual enough to merit them. What it was, in the language of the behavioral data that wildlife researchers use to track the quality of encounters rather than just their frequency, was a stalking incident. The lion had selected a target, moved to a following position, and maintained that position until the target's behavior disrupted the sequence. This is not the same as a lion that is surprised at close range and bluffs a charge before retreating. It is not the same as a mother with cubs defending a space buffer. It is an animal that has initiated the early stages of predatory behavior toward a human being and been deterred by that human's response. The distinction matters. Not because the encounter ended badly, it did not, but because the behavioral signature of that encounter belongs to a category that is increasing in frequency across the American West in ways that the standard narrative of mountain lion rarity does not adequately capture. If what you just heard made you want to understand this more deeply, stick with this. There is 15 years of wildlife data to go through, and what it shows about where mountain lions are appearing, why they are appearing there, and what is changing about the nature of their encounters with humans is more complicated and more important than the story you have been told. Subscribe if this is the kind of careful, evidence-based examination of wildlife and human ecology that you want more of. This is the kind of content that gets made for people who want the real picture, not the reassuring one. The reassuring picture is not false. That point deserves to be made clearly before anything else, because the reassuring picture is the foundation on which everything else rests, and abandoning it in favor of alarm would be both inaccurate and counterproductive to the mountain lion's conservation interests, which are real and which matter. Mountain lions, known variously as cougars, pumas, panthers, and catamounts, depending on the region and the tradition of the person speaking, are the most widely distributed wild felid in the Western Hemisphere. Their range extends from the Canadian Yukon to the southern tip of South America, a latitudinal spread that no other wild cat in the world matches. In the contiguous United States, they are present in significant numbers in every state west of the Rockies, with small and fragile populations in Florida and occasional dispersers documented as far east as the Midwest. They are large, powerful, and entirely capable of killing a human being. An adult male mountain lion weighs between 130 and 220 pounds and can bring down an elk, which may weigh 600 pounds or more, using a hunting technique that combines stealth, explosive acceleration, and a killing bite to the base of the skull or the vertebrae of the neck. Despite all of that, they kill almost no people. The confirmed human fatality record for mountain lions in all of North America across the entire span of recorded history is approximately 27 individuals. 27 people across 4 centuries, on a continent where the species has been present in the hundreds of thousands for the entirety of that period. This number is so low relative to the species' distribution, its predatory capability, and the density of human activity in its habitat, that it demands explanation. It is not an accident. It is not luck. It reflects something genuine and specific about how mountain lions perceive, categorize, and respond to human beings. And understanding that something is the prerequisite to understanding what is changing, and why it matters that it is changing. Mountain lions are evolutionary specialists. They are not generalist predators in the way that bears, or wolves, or coyotes are generalist predators. Their hunting system has been calibrated over millions of years of coevolution with specific prey species, primarily deer and elk in North America, and the prey recognition and targeting system that emerges from that evolutionary history is not indifferent to the difference between a deer and a person. A mountain lion assesses potential prey through a combination of size, silhouette, movement pattern, behavioral cues, and scent. Wild ungulates fit a template that the mountain lion's nervous system has been shaped to recognize and respond to. They are the right size. They move in characteristic ways, fluid and fast and directionally consistent when alarmed. They smell like prey. They behave, when they detect a predator, in ways that activate the predatory sequence in the mountain lion's nervous system, most importantly, by fleeing. Humans are wrong in almost every relevant category. Adult humans are the wrong shape. They are upright in a way that wild prey animals are not. They are noisier and less predictable in their movement. They produce sounds that no mountain lion has evolved a template for. And critically, when they encounter a mountain lion, the ones who do not become statistics behave in a way that is almost perfectly designed to disrupt the predatory sequence. They do not flee. They face the animal. They make direct eye contact, which is an assertive signal in the social communication of many carnivores, not a submissive one. They make themselves larger. They are loud, unpredictable, and unmistakably not fleeing. For a predator whose entire hunting system is built around the exploitation of flight, an animal that refuses to flee is categorically difficult to process as prey. It does not fit the template. The cost-benefit calculation that governs predation, which is not a conscious calculation but a neurological one, shifts dramatically when the potential prey is behaving in ways that signal high retaliation risk rather than vulnerability. This is the biological foundation of the rarity. It is solid, and it is real. But the 15-year data record that wildlife agencies, independent researchers, and citizen science platforms have accumulated since roughly 2008 tells a story that sits on top of that foundation and complicates it in ways that are worth spending time with. That record shows that the number of documented mountain lion encounters in suburban and peri-urban areas has increased substantially. It shows that the behavioral profile of a meaningful subset of those encounters has shifted in the direction of reduced lion wariness and increased close contact with humans. It shows that specific categories of humans, most notably trail runners, solo hikers, young children, and people with dogs, are appearing in incident reports at frequencies that are not randomly distributed and are not simply the product of more people spending more time outdoors. And it shows that these patterns are concentrated in specific geographic zones that correspond, with striking consistency, to areas where habitat fragmentation, prey fluctuation, and the long-term habituation of mountain lions to human proximity are most advanced. The geographic concentration is itself one of the most important signals in the data. Mountain lion encounters are not distributed uniformly across mountain lion habitat. They cluster. In California, the highest density encounter zones in the 15-year record are the Santa Ana Mountains, the Santa Cruz Mountains, the foothills of the Sierra Nevada between Sacramento and Fresno, and the coastal ranges of San Luis Obispo and Santa Barbara counties. In Colorado, the concentration is most pronounced in the foothills corridor between Fort Collins and Pueblo, where the urban growth of the Front Range metro area has pushed residential development deep into what was, 2 decades ago, relatively remote mountain lion territory. In Washington state, the highest frequency encounter zones track the expanding suburban edge of the Puget Sound Basin, where development has fragmented historically continuous mountain lion habitat into a patchwork of reserves, agricultural land, and residential areas that lions move through with increasing regularity. In British Columbia, the encounter hotspots are in the lower Fraser Valley and the coastal communities between Vancouver and Whistler, where a combination of suburban expansion and prey availability has produced a mountain lion population with a different relationship to human proximity than the animals in more remote interior terrain. What these zones have in common is a set of structural features that are not random and are not coincidental. They are places where mountain lion habitat and human settlement are not simply adjacent, but interpenetrating. The lions are not on one side of a line and the humans on the other. They occupy the same space, at different times of day, using overlapping corridors, sharing resources in the form of prey animals that are themselves navigating the human-dominated landscape. Deer, the primary prey of mountain lions across most of their North American range, have adapted to suburban environments with remarkable success. Suburban deer populations in many parts of the West are denser than deer populations in adjacent wild habitat because suburban environments provide reliable food resources, reduced predation pressure from other natural predators, and regulatory protection from hunting. A mountain lion following deer into suburban terrain is doing exactly what its biology tells it to do. It is following prey. The prey happens to live in human neighborhoods. The lion is not confused or displaced. It is hunting. The 15-year tracking data from GPS-collared individuals in the major research programs, the National Park Service study in the Santa Monica Mountains and Santa Ana Mountains, the Washington Department of Fish and Wildlife's long-term cougar study, the Colorado Parks and Wildlife Telemetry Program, and the California Department of Fish and Wildlife's statewide monitoring effort collectively paint a picture of an animal that has become dramatically more competent at navigating human-dominated terrain over the period of the study. The movement patterns of lions collared in 2008 and lions collared in 2020 in the same study areas show measurable differences in the degree to which individuals use developed terrain, approach human structures, and maintain activity during daylight hours in areas with significant human presence. This is not a species-level change in behavior. Mountain lions have not evolved to lose their wariness of humans over 15 years. It is a within-lifetime behavioral change in specific individuals in specific places, which is a different and in some ways more immediately concerning phenomenon. Behavioral ecologists use the term boldness to describe the degree to which an individual animal approaches and engages with novel stimuli rather than withdrawing from them. Boldness is a heritable trait with individual variation, meaning that within any population of mountain lions there is a distribution of boldness levels, some animals constitutionally more avoidant and some constitutionally more exploratory. In a population where human-associated terrain represents a stable resource, where suburban deer are reliably available, where the consequences of approaching human structures are consistently non-negative, selection may, over time, favor animals on the bolder end of the distribution. This is a long-term process, not a rapid one, and it is not the primary mechanism driving the 15-year trend, but it is operating in the background and deserves acknowledgement as part of the long-range picture. The primary mechanism driving the encounter trend in the near term is habituation, and it deserves the most detailed examination because it is the most tractable and the most policy-relevant element of the picture. Habituation is a universal feature of animal learning. Every vertebrate species habituates to repeated stimuli that do not produce negative consequences. The rate and extent of habituation vary by species, by individual, and by the nature of the stimulus, but the basic phenomenon is universal and thoroughly documented. For mountain lions, the relevant habituation process is the attenuation of their wariness response to human presence and human-associated stimuli. A mountain lion that moves through a suburban canyon system repeatedly and encounters humans who see it and back away, who do not chase it, who do not produce any negative outcome, is receiving a consistent behavioral signal. Humans are not a threat worth the metabolic cost of avoidance. The wariness response, which is partly innate and partly learned, erodes in the face of that signal. The erosion is not uniform and is not a simple linear function of exposure. Mountain lions appear to maintain a residual wariness baseline, even in heavily habituated individuals, that prevents the complete collapse of avoidance behavior. No mountain lion in the documented record has become fully comfortable with close human proximity in the way that a hand-raised captive animal might be. But the degree of habituation documented in the most human-proximate individuals in the major study populations is substantial and represents a meaningful departure from the behavioral baseline of wild-conditioned animals in remote habitat. Individuals in the Santa Ana Mountain study population have been documented resting within 200 meters of occupied residences, making kills within audible range of human activity, and moving through drainage corridors between housing developments on a regular schedule that shows no avoidance of the residential odor and sound landscape that would drive a fully wild-conditioned animal away. The prey switching that accompanies habituation is the mechanism through which habituation translates most directly into human safety concerns. Mountain lions are opportunistic within the broad framework of their prey preferences. When their primary prey is abundant and accessible, they take it almost exclusively. When it is scarce, or when the energy cost of pursuing it is high relative to the energy cost of alternative options, they adjust. In suburban terrain, the alternative options include domestic livestock, domestic dogs, and in the extreme end of the documented cases, humans. The gradient from deer to domestic animals to humans is not one that most individual mountain lions travel in any significant way. The vast majority of suburban adjacent lions take deer almost exclusively and have no documented incidents of domestic animal predation or human-directed behavior. But a subset, consistently documented across all the major study populations, does take domestic animals. And within that subset, a much smaller group has been documented in behaviors directed toward humans that fall into the stalking and close approach categories that precede attacks in the historical record. The domestic dog incidents deserve specific attention because they are among the most reliably documented point of contact between mountain lions and the human communities they share space with, and because the trend in dog-related incidents is one of the cleaner signals in the 15-year data. Mountain lion predation on domestic dogs increased in frequency across the western United States between 2008 and 2023 at a rate that exceeds the growth of mountain lion populations over the same period. This is not simply more lions encountering more dogs. It reflects a behavioral shift in the subset of the lion population operating in suburban and peri-urban terrain. Dogs, particularly medium to large breeds used for hiking, trail running, and outdoor recreation, present a size and behavioral profile that is in some ways closer to natural mountain lion prey than an adult human is. They move at speeds that can activate the chase response. They are often ahead of or behind their handlers in trail environments, increasing their temporal isolation. They make sounds when stressed that are not the sounds of a human and may not trigger the same behavioral avoidance that a human's vocalizations do. The documented cases in which mountain lions have killed or seriously injured dogs in trail environments share a cluster of contextual features. The attacks frequently occur when the dog has ranged beyond visual contact with its owner. They occur preferentially in low-light conditions, at dawn and dusk, when mountain lions are most active and when the visibility advantages of the terrain favor the predator. The lions involved are not always juvenile or subadult, which challenges the assumption that domestic animal predation is primarily a problem of young, inexperienced animals that have not yet learned to take deer effectively. Some of the documented dog predations in the 15-year record involve adult, apparently healthy animals that appear to have incorporated domestic dogs as a secondary prey category, alongside their primary deer diet. The behavioral flexibility this represents is significant. It indicates that prey switching in habituated suburban lions is not always a consequence of desperation or nutritional stress alone, but can represent an opportunistic extension of an otherwise successful hunting strategy. The trail runner dimension of this picture is one that the recreation community has been slow to engage with directly, and the reasons for that slowness are understandable in the same way that the reasons for wildlife agencies' cautious communications are understandable, but they produce the same kind of gap between available information and behavioral response. Trail running as a sport and as a recreation category has grown dramatically in the western United States since 2008. The number of registered trail race participants in the western states roughly quintupled between 2008 and 2020. The number of individuals who trail run recreationally without participating in organized events is larger still and harder to quantify. But the growth in trail use, measured by land management agencies through trail counter data and permit systems, shows a comparable rate of expansion. The number of human hours spent moving at running pace on trails in mountain lion habitat has increased by an amount that makes the pre-2008 baseline essentially unrepresentative of current conditions. Trail runners appear in mountain lion encounter reports at a frequency that is disproportionate to their representation in the total trail-using population. This is not a new observation. Wildlife biologists have noted it for decades. The explanation rooted in the chase response is well established and physiologically sound. A running human presents a motion profile that overlaps with the flight behavior of prey animals in ways that a walking human does not. The mountain lion's visual system, optimized for detecting and tracking moving targets, processes a running human differently than a walking one. The neural circuitry that drives pursuit, the chase response that in wild conditions is triggered by a fleeing deer, does not require a conscious decision to activate. It is triggered by the stimulus pattern, and a running human produces a stimulus pattern that is meaningfully closer to that template than a walking human does. Not identical, not close enough to consistently initiate a full predatory sequence in a wild conditioned animal, but close enough in a habituated animal whose wariness threshold has been reduced by repeated non-negative exposure to humans to produce a following or pursuit behavior that represents the entry point of the predatory sequence. The practical implication is that trail runners in mountain lion habitat are operating at a slightly but consistently elevated encounter risk relative to walkers, and, at a substantially elevated encounter risk in areas where the lion population has been documented to have a high habituation status. The trail running community's response to this information has largely been to contextualize it within the overall rarity of attacks, which is statistically appropriate, and to resist modifications to the practice that would substantially alter its character. Running with a partner reduces risk significantly. Carrying a deterrent, which may mean a walking pole, a noise device, or in states where it is legal and practical, a defensive spray, provides a response option that solo runners do not have. Avoiding dawn and dusk, the peak activity periods for mountain lions across most of their range, reduces the probability of an encounter in conditions that favor the predator. These recommendations exist in official guidance documents and have been available for years. The degree to which they are implemented by the trail running community in high encounter zones is, based on land manager observations and incident report context data, not high. The dawn and dusk timing factor shows up in the encounter data with enough consistency that it deserves to be treated as a primary risk modifier rather than a secondary consideration. Mountain lions are crepuscular and nocturnal hunters across most of their range, with peak activity concentrated in the 2 to 3 hours around sunrise and the 2 to 3 hours around sunset. This is not a rigid biological constraint. Mountain lions in isolated or human-proximate populations have been documented hunting at all hours, and the GPS collar data from the major study populations shows substantial individual variation in activity timing. But the statistical concentration of lion activity around dawn and dusk is well established, and the concentration of attack incidents in those time windows is correspondingly strong. Of the confirmed predatory attacks on humans in the 15-year record, a disproportionate number occurred during the dawn or dusk window. Of the stalking and close approach incidents that did not result in physical contact, the concentration in those windows is even higher. This is not a coincidence. It reflects the alignment of peak mountain lion activity with the recreational timing preferences of trail runners, hikers, and dog walkers who prefer those hours for reasons of temperature, light quality, and solitude. The solitude factor is the one that, more than any other variable in the encounter data, consistently distinguishes incidents that escalate from incidents that do not. The protective effect of human group size in mountain lion encounters has been documented so consistently across so many incident databases that it is one of the few near certainties in a dataset otherwise full of uncertainty and complexity. Individual humans are attacked by mountain lions. Groups of 2 or more humans are almost never attacked. The shift in risk profile between one person and 2 people moving together is not linear. It is not simply that 2 people represent twice the defensive capability of 1. It is that a group of 2 or 3 humans presents a fundamentally different behavioral and sensory stimulus to a mountain lion than a single individual does. Groups are louder in an irregular, unpredictable way. They create movement at multiple points simultaneously. They produce visual complexity that disrupts the predator's ability to focus its attack calculation on a single target. The cost-benefit math of predation changes dramatically for a mountain lion facing a group, even a small one, compared to a lone individual. This finding from the encounter data should be the most practically actionable piece of information available to outdoor recreationists in mountain lion country, because the behavior modification it implies, not going alone on trails in high encounter zones, is relatively accessible compared to some of the other behavioral changes that risk reduction would theoretically require. But it is also the recommendation that encounters the strongest resistance from the population most overrepresented in the encounter data, trail runners and solo hikers, for whom solitude is often a core component of the activity's appeal. The tension between the risk profile of the activity and the preferences that make it attractive is not unique to this context. It is a recurring feature of human risk management in recreation. But the specific version of it, playing out in mountain lion habitat, is worth naming clearly, because the gap between available information and behavioral response is not a gap of ignorance in most cases. It is a gap of preference, and it produces a risk level that is chosen rather than simply accepted. The children dimension of the 15-year record is the most sobering and the most difficult to communicate clearly without triggering the kind of parental alarm that overwhelms careful analysis with emotional response. Children appear in mountain lion attack records at a rate that is disproportionate to their representation in the outdoor recreation population. The historical record of mountain lion fatalities, those 27 documented deaths across 4 centuries, includes a substantial proportion of child victims. The 15-year contemporary record of non-fatal attacks and serious encounters follows the same pattern. Children between the ages of 3 and 10 are the most at-risk demographic in every geographic zone where the encounter data is dense enough to support demographic analysis. The biological explanation is not complicated. A child in that age range occupies a size class that is closer to the natural prey of a mountain lion than an adult human is. A child weighing 40 to 80 pounds is within the size range of deer fawns, bighorn sheep juveniles, and other natural prey species. The movement profile of a running or playing child is different from that of an adult human, in ways that reduce the behavioral distinctiveness that protects adults from mountain lion predation. Children make higher-pitched sounds. They move less predictably. They are less likely to execute the behavioral response that deters attack, the standing tall, the direct eye contact, the aggressive vocalization, partly because they do not know to do it, and partly because even if they know, the physical execution of assertive threat display behavior is harder for a small body than for a large one, and they cannot fight back effectively if an attack begins, which means that the attack, once initiated, is more likely to continue and cause serious injury or death. The policy implication of this finding is not ambiguous, and in regions where the encounter data is most dense, wildlife managers have begun communicating it more directly than was standard practice a decade ago. Children should not play unattended outdoors in areas adjacent to mountain lion habitat during dawn, dusk, or darkness. Adults supervising children in high encounter zones should be aware of the visual field around play areas and should not rely on fencing alone as a protection measure, since mountain lions are capable of scaling standard residential fencing without significant difficulty. These recommendations appear in the current public guidance of California Department of Fish and Wildlife, Colorado Parks and Wildlife, and Washington Department of Fish and Wildlife in forms that would not have been present in those agencies' communications in 2010. The shift in the guidance is a signal about what the incident data is showing. It is not a signal of crisis. It is a signal of adjustment. And adjustments, in official guidance language, tend to lag the behavioral data that drives them. The fact that these adjustments are happening is informative. The nutritional stress component of the picture is where landscape-scale ecology and individual animal behavior connect most directly, and it is where the management implications extend furthest beyond the immediate human safety context into the broader questions of how mountain lion populations function in a fragmented landscape. Nutritional stress in mountain lions occurs when prey availability falls below the level needed to sustain an individual's caloric requirements. This can happen through drought, which reduces the vegetation that supports deer populations and causes deer to decline or disperse. It can happen through disease, specifically chronic wasting disease in deer, which is now present across a substantial portion of the mountain lion's range and has reduced deer populations in affected areas. It can happen through human hunting pressure on deer populations that shares the prey base with mountain lions. And it can happen through competitive exclusion when an established mountain lion's territory is invaded by other lions, typically dispersing young males, that compete for access to prey. Nutritionally stressed mountain lions show a specific behavioral profile in the tracking data that is distinct from healthy, well-fed individuals. They move more, covering larger areas in shorter time periods in search of prey. They take prey at intervals that reflect reduced hunting success, with longer gaps between kills than healthy individuals in comparable habitat. They are more likely to investigate novel food sources, including domestic livestock, domestic dogs, and human settlements where food may be available through garbage, pet food, or other anthropogenic attractants. The combination of nutritional stress and habituation is the configuration that appears most frequently in the behavioral history of mountain lions that have attacked humans. It is the configuration that wildlife managers describe in their incident reports when they analyze the background of animals that have stalked or struck at humans in the contemporary record. The nutritionally stressed, habituated individual is not the most common type of mountain lion operating in peri-urban terrain, but it is the most dangerous type, and the conditions that produce it are becoming more common, not less, as the structural features of the Western American landscape continue to develop in the direction of more fragmentation, more suburban encroachment, and more competition for a prey base that fluctuates in ways that human landscape modification exacerbates. The fragmentation dimension is where the 15-year picture connects most directly to policy decisions that are currently being made and that will shape the human-mountain lion relationship for the next several decades. Mountain lion populations across the western United States exist within a landscape that is becoming progressively more compartmentalized. Major highways, suburban development corridors, agricultural barriers, and other hard features of the human landscape divide what was historically a continuous distribution into an increasingly fragmented mosaic of subpopulations. In the most developed regions, the subdivision is extreme. The mountain lions of the Santa Ana Mountains in Southern California effectively inhabit an island. The freeways, Interstate 15 on the east and Interstate 5 and State Route 241 on the west, have reduced the genetic connectivity between that population and adjacent mountain lion populations to a trickle. The demographic consequences are visible in the telemetry data and the genetic sampling. The population is small. It is showing elevated inbreeding coefficients that are producing measurable effects on reproductive success and cub survival. The carrying capacity of the range, limited by its total area and prey base, constrains the population to a size that is demographically vulnerable. The individual-level consequence of population confinement is the same across all the isolated populations in the dataset. Young males, which in a connected landscape would disperse over long distances to find unoccupied territory, are trapped. They cannot disperse across the freeways that bound their birth range without an extraordinarily high risk of mortality from vehicle collision. A disproportionate number of mountain lions killed by vehicles in Southern California are young males between 1 and 3 years of age, the age class that would normally be dispersing. Those that do not attempt crossing are pushed into a competitive environment within the confined range that drives them into marginal habitat, including the suburban edge, where food availability and avoidance of dominant resident males may keep them alive, but in conditions of nutritional and competitive stress. The young, dispersal-frustrated, nutritionally marginal, peri-urban male is the individual that appears most consistently in the behavioral histories of high-risk encounters. It is also the individual that landscape fragmentation produces most reliably. Wildlife crossing infrastructure is the most direct structural remedy available for the population-level consequences of landscape fragmentation. and the 15-year period under examination has seen both the most ambitious wildlife crossing project in North American history and a rate of overall crossing construction that falls far short of what the scope of the problem would seem to require. The Wallace-Annenberg Wildlife Crossing over the 101 Freeway in Agoura Hills, California, which was completed in 2023 after more than a decade of advocacy, fundraising, and design, is genuinely significant. It will, if lions use it at the rates that corridor ecology models predict, restore meaningful genetic connectivity between the Santa Monica Mountains population and the larger lion population of the interior. The demographic relief it provides to a population showing inbreeding effects will take time to manifest, but the trajectory is positive, and the project represents a proof of concept that the engineering and funding challenges of major wildlife crossings can be overcome. What surrounds that achievement is a landscape of infrastructure deficits that the crossing's visibility should not obscure. The mountain lion population of California, of the Pacific Northwest, of the Colorado Front Range, of the Greater Yellowstone ecosystem's boundary zones exists within a road network whose wildlife crossing infrastructure covers a fraction of the barriers that corridor ecology identifies as critical. The intervals between existing crossings on most major highways in mountain lion territory are long enough that dispersing young males moving through those sections face collision mortality rates that substantially exceed what a connected landscape would produce. The relationship between that mortality risk and the behavioral profile of the animals that survive to operate in peri-urban terrain is not linear and is not perfectly understood, but the direction of the effect is not ambiguous. The animals that survive in the confined, fragmented landscape are, on average, the animals that are more comfortable with human-dominated terrain than those that do not survive. This is a selection effect, operating in real time on the behavioral composition of the mountain lion populations closest to the highest concentrations of human settlement. The management toolkit available to wildlife agencies for the near-term human safety situation is real but limited. Lethal removal of problem individuals, defined as animals that have stalked humans, entered residential areas during daylight, or demonstrated the behavioral profile associated with elevated attack risk, is standard practice across all Western states and has a sound justification in the immediate human safety context. The removal is rapid, and the operational capacity to execute it exists. What it does not do is address the conditions that produce the individual. The next young male pushed into the peri-urban corridor by population pressure and dispersal barriers faces the same habituation gradient, the same prey fluctuation, the same nutritional stress risks as the one that was removed. Individual removal without structural change to the landscape and management conditions that produce high-risk individuals is a maintenance strategy, not a solution. Non-lethal deterrence tools and hazing programs represent an intermediate option that some jurisdictions have explored with mixed results. Hazing, the deliberate exposure of an individual lion to aversive stimuli designed to reinstate avoidance of human presence, can reverse habituation in individual animals in contexts where it is feasible to implement. The practical challenges are substantial. Hazing requires repeated, consistent aversive conditioning, typically delivered by trained wildlife officers using rubber projectiles, noise devices, or dogs. In the field conditions of suburban terrain, achieving the consistency required for effective behavioral reversal is difficult. The lion must be hazed every time it approaches human areas, not most times. Inconsistent hazing can produce an animal that has learned to distinguish hazed situations from non-hazed ones, which is a more behaviorally sophisticated and in some ways more dangerous outcome than simple habituation. The resource requirements for effective hazing programs at the scale of the encounter density in high overlap zones are substantial and not reflected in current wildlife management budgets in most jurisdictions. Community-level behavioral changes in the human population represent the third element of the management response, and they are simultaneously the most widely recommended and the least systematically implemented. The guidance exists. It is available. It is communicated through official channels, through recreation community organizations, through land management agencies' signage and public information programs. The implementation of that guidance in the behavior of the actual humans moving through high encounter zones is inconsistent in ways that the incident data reflects. Trail runners still run alone at dawn in known mountain lion corridors. Dog owners still allow dogs to range off-leash in areas where lion predation on dogs has been documented. Parents in subdivisions adjacent to mountain lion habitat still let children play unsupervised in yards that back onto drainage corridors that lions use regularly. None of these behaviors is irrational given the low absolute probability of an attack. All of them are higher risk than the alternative. The gap between available guidance and implemented behavior is not a problem of information. The guidance is accessible. It is a problem of how human beings process low probability, high consequence risks in contexts where the activity they would need to modify is one they value highly, and where the historical outcome has been overwhelmingly safe. The public communication challenge that wildlife agencies face in this environment is genuinely difficult, and it deserves acknowledgement as such, rather than simple criticism. The agencies are managing multiple objectives simultaneously. They are responsible for human safety. They are responsible for mountain lion conservation. They operate in a political environment where the mountain lion's status is contested, where hunting access debates overlap with conservation funding debates, and where public alarm about attack risk has historically been weaponized by interests that would prefer reduced mountain lion populations. Communicating that attack risk is real and increasing, even modestly and from a low baseline, in that environment is a politically and institutionally complex act. The default toward reassurance, toward emphasis on rarity, toward downplaying trend information that might feed public alarm, is not simply bureaucratic timidity. It is a response to a genuine communication environment where the consequences of over-communication in the direction of alarm have historically been bad for mountain lion conservation. The problem is that the consequences of under-communication in the direction of reassurance are now also bad, not for mountain lion conservation directly, but for the humans who are experiencing a risk landscape that has quietly changed from the one that the reassuring messaging was calibrated to describe. The 15-year data is not alarming in the sense that it describes a dramatic break from historical safety baselines. The absolute numbers remain low. The probability of being attacked by a mountain lion on any given trail run or hike remains vanishingly small compared to the other risks built into daily life. But the direction of the trend, the behavioral profile of the encounters driving it, and the structural conditions that will continue to produce it regardless of what happens to the underlying mountain lion population in the near term, collectively describe a situation that has changed enough from the 2008 baseline to warrant an update to the public conversation that has not yet happened at the scale and with the specificity that the data would support. The update does not need to be alarming. It needs to be accurate. It needs to acknowledge that the encounter frequency in peri-urban terrain has increased, and that the behavioral profile of a meaningful subset of those encounters reflects habituation and reduced wariness, rather than random chance. It needs to acknowledge that specific categories of recreationists, trail runners, solo hikers, people with dogs, and most urgently, parents of young children in mountain lion-adjacent communities face a risk profile that is meaningfully different from the profile that existed when the historical baseline of extreme rarity was established. It needs to acknowledge that the structural conditions producing this shift are not going to reverse themselves in the absence of deliberate action, and that the action required, wildlife crossing infrastructure, habitat management, community-level behavioral change, and institutional willingness to communicate risk accurately, even when doing so is institutionally uncomfortable, is not beyond the capacity of the jurisdictions involved, but requires a political and institutional commitment that the current level of public awareness does not yet support. The mountain lion is not becoming a human predator. That statement remains accurate and important. The species has had 4 centuries of opportunity to develop a predatory relationship with humans at a scale that would produce a different historical record than the one that exists, and it has not done so. Its fundamental behavioral template, built over millions of years of coevolution with prey animals that are not human beings, remains intact and continues to suppress predatory responses toward humans in the overwhelming majority of encounters. The behavioral evidence for this is in the encounter records themselves, which show hundreds of non-incident sightings, calm withdrawals, and mutual avoidance for every stalking incident, and thousands of stalking incidents for every actual attack. The mountain lion's default relationship with humans is avoidance, and that default is robust. But defaults are not absolutes, and the conditions under which the default is being tested are becoming more common, not less, in the parts of the American West where the human footprint in mountain lion habitat is deepest, and where the population dynamics of fragmented lion populations are producing the behavioral profiles most associated with elevated encounter risk. The gap between what the historical baseline tells us and what the 15-year contemporary record is describing is where the real work of understanding this situation needs to happen. It is a small gap in absolute terms. It is not a small gap in what it implies about the trajectory of the relationship between human communities and the mountain lions that increasingly share their landscapes. The 15 years of wildlife records that document this shift are not secret. They are available in state wildlife agency databases, in peer-reviewed ecological literature, in the incident reports that form the operational record of wildlife management agencies across the western states. What has been missing is the synthesis of that record into a clear and honest public account of what it shows. The pattern is there. The trend is there. The structural drivers are there, and they are understood well enough to point toward the specific places and the specific management decisions where the trajectory could be altered. What it takes to act on that understanding is a willingness to have the accurate conversation rather than the comfortable one. The comfortable conversation, the one that emphasizes rarity and statistical context and the biological magnificence of the mountain lion, is a true conversation. It is not the only true conversation that the data supports. The other one, the one about where the trend is going and why, has been waiting in the data for 15 years. It is time to have it.